Hello, my name's Nigelargriffiths. I work in blah blah blah. You've heard this all before. In this movie, we'll be looking at the virtual I/O server shared storage pools, in particular migrating the other disk technologies into a shared storage pool without downtime and to enable live partition mobility. I've used this picture many times to show and remind people of the various storage options we have with the VIOS. The first two original sorts of disks were the logical volumes and the whole disks. These are connected local disks to the virtual I/O server, and they're presented over virtual SCSI to the client virtual machine or LPAR. The client virtual machine just sees virtual SCSI devices. It can't tell how the data is actually stored at the back end, the other side of the virtual I/O server. Number 3 was LUN attached. So this LUN is connected to the virtual I/O server and online there, and again it's presented over virtual SCSI here. Number 4 is these filed backed ones, where we actually create a large file system on the virtual I/O server disks, and then we present a large file to the clients again. It sees another virtual SCSI disk. It can't tell how it's done at the back. Number 5 is NPIV, Endpoint ID Virtualization. This is a LUN that's presented. The virtual I/O server doesn't really have it online. It sends the packets to the client virtual machine over virtual fiber channel. The VIOS is behaving a bit like a SAN switch in this case, just passing the packets to the right person. The client actually has these disks now online, these LUNs, and it is aware of the back-end disk subsystem. That is nice for the storage people to know who's actually using the disks. It's bad because you have to install the device drivers in every single client VM. So you may have to install those 100 times for 100 different LPARs, instead of the other way of doing it, installing it once or twice in your virtual I/O server. That can be not too bad unless you need to update those device drivers. Number 6 is the shared storage pools, where we have LUNs at the back end. These are given to a group of virtual I/O servers running in a cluster, and the LUNs make up this thing called a storage pool. The virtual I/O servers cooperate then in allocating particular blocks on these disks to particular clients. So we've collected a group out of the pool in here and made this disk. This is presented again as the virtual SCSI device to the client. Again, the client can't tell what's actually at the back end. These all look the same. This is really nice because these client virtual machines or LPARs already understand how to operate these, and so AIX, IVMI, and Linux for Power all can just connect up and use these as they have done in the past. Now we're using this as an introduction because the idea is we're going to move to storage pools from some of these other technologies on the fly, and then we get the benefits of the shared storage pool, efficient storage use, and we're live partition mobility ready. I'm going to take you through a little worked example of what's going on. I'm assuming here that it's AIX, but I think this will work just as well with Linux on Power and IBM I. We just need the ability to replace a disk with a new disk. Typically we use mirroring to do that, to keep it all live and concurrent. Here we have a small storage pool and 2 VIO servers. They're probably hosting a whole bunch of clients in here. Over here we've got perhaps an older machine using some of the older technology. And they probably started off with some local disks on the VIO server and connected up a client and used that. They probably ran out of space, so then they said, okay, now we've got some LUNs online, let's use the virtual SCSI to add some more disk space. And then later on NPIV came in, and that's all the rave, and so they then added some NPIV LUNs as well. We actually have a client up here that's a bit of a mess. It's got 3 different technologies in here, and it would be nice to clean that up. And of course we can't do live partition mobility here because there's a local disk attached, and we can't do that. The first thing we need to do then is to stretch our shared storage pool to include this VIO server over here. We just run the cluster add node command, and the cluster name and the host name of the VIO server. Quite easy to do. We can do that all live. So in part 2 then we can add these logical unit disks to the right LPAR. We can make them the same size if you want to keep things simple, so that we can just copy the data from the older disks, or we might decide to reorganize them. We might decide rather than 3 disks just go down to 1 disk, and because we know at the back end we're doing RAID 5, so we don't need local mirrors, for example. Then we get these logical units online and in the right volume groups, and we can start moving the data. The way to do this online is, of course, to mirror them, resilver, and then break the mirror. On AIX, we have the migratepv command. We'll do this all online and make life very simple for us to do this operation. We need to do the boss boot and boostlets commands so that we can restart the client VM and boot off the new set of disks. And then if we have any mirrors left, we can remove those. Then we can remove those older disks. This is quite a nice feature and make life simpler. Maybe we will migrate to a few larger disks rather than lots of little ones, for example. Then all of a sudden we have the ability to do live partition mobility across our shared storage pool. Very nice feature that has been added in here, as well as simplifying things. We actually have this great tool where we can use live partition mobility to do load balancing in the computer room and to evacuate a machine if we need to update, for example, the firmware or add new hardware to it. We also have the ability that if this was actually an older machine, then we could actually decommission the machine or repurpose it for something else completely. It's a good way of removing an older machine and getting live partition mobility and sorting out some older disk configurations all in one go. As the Borg would say, you have been assimilated. So here's a little summary of what we're going to do. We've got a AX7 client, Bronze 2. It's just got a single disk to keep things simple. We've got a VIOS server called Bronze VIOS server 1. That's at the current level of the VIOS server. And we've already added it to the cluster called Galaxy, and the shared storage pool LUNs have been zoned into it beforehand. What we're actually going to show you is creating that logical unit disk from the shared storage pool and giving it to Bronze. Then we need to get that online. All these blue ones are just regular AIX system admin. There's nothing rocket science in here. We're going to do the reduce logical volume size of the file systems. That just means we have to copy less between the two disks. The migratepv is going to do all the hard work for us. Just takes a couple of minutes in this case. Then we're going to do the boss boot and boot list command so that we can boot off our new shared storage pool disk. And then we are not using the old disk, so we pull those out of AIX, and then we go to the VIO server or the HMC and actually disconnect those old drives. Now we can actually keep those around just in case. It's a nice little parachute, but we don't actually need them anymore, and we can release that disk space later on. Then we're actually ready for live partition mobility. Really is that quick. So here's my HMC, the Bronze machine. Here's the Bronze 2. It's a project I'm working with Alice on the Power SC real-time alerts. And it's actually hosted on the VIO server in here. It's a logical volume on the VIO server, so we can't move it about, and it's not very flexible. So I need to first of all have a little look at it. And here we have Bronze 2, and I've got just one disk, LSPV. You can see down here it's 16,000 megabytes, so 16 gig. There's 3 gig unused, so we've got some space in there. And so I need to create a logical unit of 16 gig, and we'll be fine. So we go to the HMC and select the machine. I'm going to use the graphical user interface as it's pretty quick, saves me having to think. Virtual resources, virtual storage. Bring it onto the screen and we'll query. We can see here the client 2 has 16 gigabytes. It's in a logical volume here, but we want to move it to storage pools, so let's show those as well. And we can see Bronze 2. In fact, the Bronze VIO server hasn't any logical unit disks, so we'll create one now. Create virtual disk, bit of a giveaway. Virtual disk name, well, it's my little convention in here. my pool in here, we'll give it 16 gig, and we'll assign it to bronze 2, and we'll go thin provisioning. Only one VIOS server, so that's the one we use. Okay. It's done it. It's requerying the VIOS server. Go back to the machine now. We're on the clear the screen. Let's try again. Clear the screen. Then we'll run the config manager. And we have a second disk. Good. Now we can either run a command or use Smitty to add that disk to the volume group. So let's try Smitty, LPM, volume group, set the characteristics, add a physical volume to a volume group. Good. Force it. There's no need, it will be brand new. Just the volume group, and the only one we got is HDisk1. Locate that. Okay, we're in. Come out there, and if we do LSPV, and now it says they're both in the volume group. Before we migrate, let's just check something. Okay, we can see some file systems here with 5 gig of space, but nearly 5 gig free. If we just move that, it will have to copy the physical partitions for the 5 gig. But we can do a quick dodge here. If we just reduce this file system to smaller sizes, because we'll only mirror the logical volumes, if we make them smaller, the mirroring will be a lot quicker. So let's just do that now. So let's change home to 128 megabytes in size. It's nice and quick. Our temp can probably be the same. Let's make a few other little changes. 256. Nope. Sorry, I forgot the M. Let's get that right. Okay. Same thing for opt. Okay. Much smaller. Let's do this migrate operation. Okay. Gives us something to read in here. We need to switch off the boot partition on the first disk so we can't accidentally boot from it, which we'll have to do anyway. And it's reminding us that the boss boot and boss list commands need to be run. We'll just let that run now, and I'll tell you how long it takes. Well, I clipped about 1.5 minutes out of the movie. The migratepv took 1 minute 50 seconds. I was surprised that's quite quick. I was looking at nmon while it was running, and we're running at 25 megabytes a second. That's just about the speed of a single internal drive. We're throwing it into the shared storage pool, which of course is on a nice caching RAID 5 spread out across lots of disks. Disk subsystem, so it was just soaking up as much as we could get off the internal drive. Okay, clear the screen. We're going to run boss boot. It normally puts it on HDisk 0, but it's not there, so explicitly put it onto HDisk 1. Takes a little while to build the image and then write it out. Then we need boot list minus normal mode HDisk1. Yep, helps if I spell it right. Okay, we're good to go. We can now remove those older disks. Disk is busy. Okay, so we need to take it out of the root volume group. Reduce volume group, root volume group, HDisk 0. And we'll run the run arrow move. It's back to the defined state. and it's actually deleted. So we can go back to this panel in here. We can see the disk is here. We'll select it and we'll modify the assignment. It's saying, whoa, it's actually connected at the moment. Assign it to none, and we'll force it to do that, as we know AX is not actually using it. Last thing about this is the disk will actually still be there, so if we've done anything wrong or it won't boot or something, we still have the original disk, and we can leave it there for a month, then perhaps delete it later on. Okay, so it's not assigned, and we're okay. Let's just check our optical devices here, that these aren't connected. Okay, that's true, so we're good to go. We could actually try Operations Mobility, validate live partition mobility. Let's try on the same HMC. Gold, yeah, that's good. This is good. This is good. This is good. Validate. And it's warning us about the slot numbers can't be maintained between the source and the target virtual I/O server. Well, I really got better things to do than worry about maintaining slot numbers. So we're good to go. Let's do live partition mobility. So we'll just hit migrate and off it goes. This will work with no problems whatsoever. If you want to see more about live partition mobility with shared storage pools, well, there's a different movie for that. Well, that concludes my You Will Be Assimilated movie about shared storage pools, live migrating your disks into the shared storage pool without any downtime, and that enables live partition mobility. Really good technology for making your life easier in the computer room. It lets you consolidate and clean up from those older disks. It allows you to go to thin provisioning in the shared storage pool, probably on the latest SanDisk too. It allows you to make your LPARs a lot simpler to operate, lower and consistent set of disks, and it's certainly easier to manage your disk space. It also allows you to decommission or repurpose some of your older machines. It'll be really nice with some of them that have been around a long time. Just get all the LPARs off it, completely refresh and rebuild some of the machines so that they're in a nice clean state. Now don't forget, this is part of the movies that I've been creating recently on the shared storage pools. Recently did one on recovering from a crashed machine using shared storage pool. Take about 2 minutes or so. Also the live partition mobility one, and then we were looking around the shared storage pool using the commands and the HMC. Go look for those on YouTube /user/nigelargriffiths.